How is it that we find ourselves surrounded by such complexity, such elegance?
The genes of you and me, the genes of you and me, they're all made of DNA. We're all made of the same chemical DNA. We're all made of DNA.
Hi, you're listening to DNA Today, a podcast and radio show where we discover new advances in the world of genetics. From genetic technology like CRISPR to rare diseases to new research, we have you covered. For a decade, DNA Today has brought you the voices of leaders in genetics. I'm Dineen. I'm a certified genetic counselor and your host. Support for DNA Today comes from the People for the Ethical Treatment of Animals, also known as PETA, whose scientists have developed the Research Modernization Deal, a strategy to phase out ineffective experiments on animals with high-tech, state-of-the-art research. PETA has collected an abundance of evidence demonstrating that the use of animals in biomedical research hinders scientific progress and puts patients at risk. Learn more at peta.org/New Deal. Again, that's peta.org/New Deal.
This is Beverly Mills, and I am lifting the veil today with Elaine Buck.
I'm Elaine Buck. I like to be called Lady Elaine. And it's good to be back.
And we have a special guest with us, and her name is Kira Dineen.
Hi, guys. How are you?
How you doing?
Hi,
We were just talking before that we were both on vacation. You were on vacation. We were on vacation. So now it seems like it's back to normal. Getting back to normal can be good and bad in a way because you're getting back to a routine, but then again, it's like, oh my God, look what I have facing us. But September is here.
Yes, back to school and for us, back to work in our lives, right?
Back to work in our lives. When we met back in June at New Pod City's Podstock event in Trenton, New Jersey, you made quite an impression on us, and that's why we're so happy that we were able to speak with you today because of your work in genetics and your podcast is DNA Today. September is Sickle Cell Awareness Month. I believe you brought that up at the podcast event, and we didn't know anything about that. And so it's something that our listeners need to know. But before we do that, we want to talk about you, your credentials, because, girl, you're something else, because you really impressed us back in June.
Well, thank you. That's nice of you. And it's cool that we actually met in person, which to me is still like blowing my mind that, you know, throughout this whole pandemic, I meet people virtually and all that, but we actually met in person, which I think just, you know, cultivates such a great connection right off the bat. So, yeah, it's just been fantastic to be connected with you.
I mean, everybody was impressive, but we just really you stuck in our mind.
We were talking about sickle cell. I said, I wonder exactly what is sickle cell disease. I have a couple people that I know that have sickle cell, but I wasn't really sure exactly what is sickle cell disease.
Sure. I think that's a good place to start is we are talking about all this, and it's more common than I think people realize. So sickle cell is a genetic condition that is inherited, and it causes different symptoms in a person that can be really painful, what we call sickle cell crises. And so how this works is in order to inherit sickle cell, both biological parents need to be what we call a carrier for the condition. They probably aren't affected by any symptoms. They probably don't even know they have it, that they're a carrier. But if they have a child with someone else that's a carrier, there's a 25% chance that their baby will inherit this sickle cell. And so that's kind of the, like, how does it happen? Now, how it actually affects a person, what a sickle cell is it's a red blood cell that is a different structure than a normal red blood cell. So my red blood cells are kind of a donut shape where it's really thick on the outside and then it's really thin in the middle. So if you think of a donut with like instead of a hole, just like a little bit of the dough there in the middle. So mine can flow through my, arteries, veins really smoothly. Now, if I compare that to someone that has sickle cell, their red blood cells are not this healthy donut shape. Theirs is, just like the name, sickled shape. Mm-hmm. So if we think about it, I think it's a quarter moon, something like that. So that's more of the shape it is. So then it can't flow as easy. It gets stuck. And this is causing what we call these sickle cell crises, which are really painful episodes Obviously, I've not experienced this myself, but from talking to people with sickle cell, that's what I've learned. And we certainly hear from people in the genetic community that have conditions. This is one of the more painful conditions that people can have. So a bit of background, how it works, and then what the actually condition is.
So, one of the reasons why we were so interested in speaking with you is because back in June, we did a session with Raquel Jeffers and Joey Toussaint Parrish, and they were talking about doulas and the Black mortality rate and some of the challenges that Black women are still facing today as far as maternal care, and how New Jersey is shockingly 47th highest out of 50 states with the highest maternal mortality rate. And when we talk about these disparities within the healthcare system with anything to do with Black and white healthcare, here we have another example of what we're talking about. And I know that we mentioned sickle cell versus cystic fibrosis, for instance, and that both of them are inherited disorders that could require frequent hospitalizations, et cetera, et cetera. But there seems to be disparities in how much attention actually goes towards research, how much attention is actually gone that the federal government has put towards looking into these diseases. Can you talk a little bit about what you know about these disparities in between research and findings between sickle cell and cystic fibrosis?
Yes, I'm so glad you brought that up, because there was a study in 2020, so about 2 years ago, in JAMA, which is a scientific journal, that explored the differences and the disparities, as you're bringing up, with cystic fibrosis and sickle cell. So the ways in which these two disorders are similar, it's the same inheritance pattern. So as I described, both biological parents need to be carriers for these conditions for there to be a chance for the biological child to inherit that. It also is similar, as you said, multiple hospitalizations, and there's a lot of similarities and overlap with these conditions. So it's interesting when we compare them, because as you brought up, cystic fibrosis mostly affects white people. Mm-hmm. Sickle cell mostly affects Black people, people that have African ancestry. There's so many disparities, and this article is fantastic. I think you guys should link to it in the show notes. I can send it to you. Mm-hmm. It pulled data from a whole decade, from 2008 to 2018, mm-hmm. and looked at, let's compare these two conditions. Let's look at how much research is being poured into these conditions, how many articles are ending up coming out in journals, how many drug approvals, how much federal funding, how much foundation funding. And all of this that I've mentioned is different, where cystic fibrosis is getting much more support in these areas compared to sickle cell. The only area where I would say they're equivalent and on the same level is how many clinical trials there have been. So that's a similar number. Everything else is different. And what I think is so interesting with this, and really quite disturbing, I would say, I'd go that far, is that talking about in the United States specifically, about 90,000 individuals have sickle cell disease. So you're talking about almost 100,000 people. Maybe it's 100,000 at this point, because the state is a little bit old. Now, when we look at how many Americans have cystic fibrosis, that's 30,000. There's 3 times more people with sickle cell than cystic fibrosis, but yet cystic fibrosis ends up getting way more federal funding, way more foundation spending. They get 11 times more federal funding than sickle cell. That just doesn't make sense to me. As much as, I've done a whole series on DNA Today, the podcast that I host, about sickle cell. It's certainly a condition that I support all of the research and everything, but I'm like, hold on, shouldn't we be having as much, if not more, to go towards sickle cell? And is a lot of this because sickle cell mostly affects people that are Black and that have African ancestry? So this is something that is just really boggles my mind. This is a huge healthcare disparity, as I think, Bev, you were mentioning that you brought up.
It angers me. And we do these podcasts, Elaine. We talk about this.
Yes, we do.
All the time, because frankly, it's exhausting. It truly is exhausting when you even consider that people that are afflicted with sickle cell disease are 3 times more than people that are afflicted with cystic fibrosis, and how much more federal funding is put towards cystic fibrosis. I hearken back to the conversation that we had with the doulas, and I still can't get over those rates because we knew nothing about it. Elaine and I talked about that and how in New Jersey, Black women are 7 times more likely to die from a pregnancy-related issue.
And that's a shocking statistic.
It's a horrific statistic, and that the Black female mortality rate is almost equal to like a sub-Saharan African community. It's New Jersey is woefully just inadequate. And no one knows about this, and no one talks about it. And we talk about,
It almost seems like no one cares.
It does.
And we do care. That's why we have these podcast talks and conversations. We say they're hard conversations, but what's so hard about it? Let's just lay the facts out on the table so people will know. We have to educate people in these areas so that we won't continue on. These statistics need to start dropping instead of getting worse.
Well,
and it sounds like that's what's going on here.
I keep bringing it up. You know someone that has sickle cell.
Sickle cell. I know several people.
Fortunately, I don't know anyone that has sickle cell or a family member, but my mother died from neglect of her proper treatment after she had my brother back in 1968. Which seems like 1,000 years ago, but not really. She was considered old, for lack of a better term. Mother, she had my brother at age 40, and I guess back then that may as well have said she was 65 years old. I don't know. But the woman passed away. The woman passed away from a blood clot that went to her lung, and it was something that she was complaining about. She complained for almost a month after his birth that she did not feel well. That's something, she knew her body. She knew something was not right, and she was continually dismissed. So when we look at the Black community, and I know, unfortunately, there has been distrust because of all the ethical violations and all the abuse and everything that's happened to us as a Black community throughout this country, you can see almost why some people with sickle cell might be hesitant. Do you think that part of it is also there's a hesitancy? I'm pretty clear on why there's a difference in funding and why there's a difference to attention.
Yeah, I think with this, it's so hard because in history, we look at medical and science history. I'm sure you guys have mentioned on the show. I think we even talked about Henrietta Lacks is a perfect example of someone that a Black woman and a Black family that were taken advantage of by scientists and doctors and were not fully informed on the information. So as just a little background for those that they're like, Henrietta Lacks, that name sounds familiar. She was a Black woman that had cancer. And back then, this was, I don't know if I'm going to get the decade right. I want to say the 40s. Back then, it was common for doctors to take samples from Black patients and see if they could do some testing from it. It's common now as well for everybody, but nowadays you sign waivers. You are informed what's going to happen. You're signing rights and away, or you're saying, I'm informed by this. Someone explain this to me. That was not the case back then. Informed consent didn't exist. So these cells became infamous because it allowed us to be able to culture cells. So it allowed us to say, oh, we can figure out how to grow cells in the laboratory, which has led to countless medical advancements. Every person on the earth has been affected by Henrietta Lacks for the better. So many vaccines have been developed because of Henrietta Lacks cells. I mean, it's just endless. But it comes back to this family was not informed it was happening. Henrietta Lacks died from the cancer, which was common back then as well. But the family was not informed about any of this. And at one point, doctors came to the family and said, oh, we need blood from each of you to have a sample so that they had a little bit more information in terms of the family genetics. And the family was not informed they were thinking, they said something like Henrietta Lacks cells, like alive. And so they were like, they have our Henrietta, she's alive somewhere, and not understanding it's her cells and it's not necessarily, her as a human that's alive. And they were waiting, like, oh, we're waiting on results to see if we have what she had. And there was just such disturbing lack of communication between these healthcare providers and for her family, her descendants that were left, and her partner, her husband, and her children that were all really having these blood samples collected. From my perspective, I don't think the Lacks family have really been compensated or honored in the way that I would like them to be honored. There's certain ways that they have been, but I don't think it's enough, because you think about all these labs that have made so much money off of what we call HeLa cells. So it takes the first 2 letters of her first name, Henrietta, and the first 2 letters from her last name. So it's HeLa, HeLa cells. And companies have made a lot of money selling these cells. And most laboratories you go into, biolabs, you have samples of it. I remember the first time I was in a lab and I was like, wow, there's Henrietta cells. Like, I had a moment where I was like, wow, there they are. And it's cases like this that people in the Black community know about this, as well as the Tuskegee trials and so many different things. And I'm sure there's so many things that you could educate me on of other things that create distrust. And it makes sense. As healthcare providers and medical professionals, we need to step up, I think.
Going back to Henrietta Lacks and how much money was made from different laboratories, for the last, 75 years or so, we're talking billions and billions of dollars.
Yes.
At least millions, but I would think maybe cross the billion. Yeah.
Yeah. I know that there was a movie or a made-for-TV movie about it, but as far as I don't really think that the Black community really knows how significant her contribution was, what it really meant. I mean, this woman changed the course of science. Ma'am, am I overstating?
You're understating, if anything.
That's right. And every woman should be thankful for her.
Oh, gosh.
Yes.
Absolutely.
I think about her when I get my checkups, and I think, just one woman started really all of this so that we can live the kind of lives that we live now. But I just found out about her, 5 years ago from my granddaughter that was reading the book or had read the book. And she said, Mom, you need to read this. And I couldn't put the book down. I mean, it was the quickest book I think I've ever read. When I did see the movie, it tried to do justice. But I mean, it really, you can't do justice for all of these things that have happened to Black women in particular. I always go back to J. Marion Sims, the father of gynecology, and how he used the young women without anesthesia. I just think that we just have to make sure that people are aware, and that's why we do what we do in our podcast, lifting the veil. We appreciate people like you, Kira, that are telling us the information and the statistics that we need to know, and we need to try to help change what's going on. I mean, this is disturbing.
So how do we change? One of the ways to change is to talk about these things, to be honest about these things, even though it may be uncomfortable. How do we talk about these things? I think it's safe to say is because it's associated with a quote-unquote Black disease that right from the gate, it's not going to receive the proper attention from the medical community. It's not going to have the same type of care. I mean,
and I think the same type of media attention as well.
When I think about the 2 young ladies that I know that died from sickle cell disease, I mean, they were young. They were not even in their 20s. They're both gone. And I just wonder, was there something that could have saved them? Were they getting the right treatment? I don't even know what the treatment is for sickle cell. Is there like a certain treatment that people should know about?
Yeah, that's a great question. And I also think myself, I had a classmate in high school that died from sickle cell, and he was just such a light to any room he came in. He was just the funniest guy, most charismatic. It really hits home when you know someone that has a disorder that passes away from that, especially at a young age. I think we were either seniors in high school right after graduation that he passed. And it's heartbreaking, especially when you know someone. It just becomes much more human to you, I think, when it's not a statistic. In terms of looking at treatment, and I even want to put the word cure out there for sickle cell, there is a light at the end of the tunnel. So I don't know, have you guys heard of CRISPR before?
No.
No?
CRISPR is really, really interesting. If you ever want to like pick a genetic topic to like go down a rabbit hole with, CRISPR would be it. It's an acronym. So it's spelled CRISPR. So it's kind of CRISPR without the E.
Okay.
And so what CRISPR is a genetic editing technology that allows us to, if you picture DNA like a piece of yarn, CRISPR is like scissors that go in and cut a piece of the yarn out and can put a new yarn, say it's a different color, take a new piece of yarn and then tape it in and fix it. So if you think of that like your DNA and you have a gene, so for sickle cell, that's the HBB gene, and people that have sickle cell have one single letter that's different in their DNA that causes the condition. Using this CRISPR technology, we can cut out the piece of DNA that has the incorrect letter, and then we can paste a section of DNA that has the correct letter, and essentially I'm kind of quote unquote fix the condition. I don't like that term, but I think for understanding the condition, that's helpful to think of it that way.
Right.
Or understanding CRISPR. Mm-hmm. So this has been a game changer and will become a game changer for all genetic conditions theoretically. And what's really interesting is that sickle cell is one of the first, if not the first, inherited genetic conditions that has clinical trials happening right now using CRISPR. In a lot of ways, I think this really helps with the attention of sickle cell in terms of the media, people learning about it, people just in the general scientific community, because this is huge. I've been waiting for like 10 years since I learned about CRISPR. And like, you know, when my show started in 2012, I was like, ooh, this is interesting. I want to keep following this and see the developments throughout my career, really. And so in March of 2021, so about a year and a half ago, it was the first FDA-approved CRISPR test for sickle cell at UCLA through the Innovative Genome Institute. And so this is connected to Dr. Jennifer Doudna, who is one of the winners of the Nobel Prize for the discovery and development of CRISPR. So it's really cool that this is happening in real time. I think this is going to bring a lot more attention to sickle cell and hopefully a cure.
Well, and you know, I'm wondering if my friend who passed away, my beautiful friend who passed away from sickle cell, I'm wondering if she even knew that, you know, this was an inherited disease and both parents are carriers. I'm wondering if the parents knew they were carriers.
Probably not.
The information, because how much were they told? How much did they understand? How much were they, informed about what their condition was?
So this is encouraging.
It is very encouraging.
Yeah, I mean, I love the new technology and the way things are fixable. Before it was, like cancer was when somebody said you had cancer, you thought, oh gosh, I'm going to die. And, so, I mean, this is wonderful that there are people that are out there testing and making up new treatments.
It sounds like when you're talking about you taking that one piece and almost snipping it out, and it sounds like a cut and paste.
Yes.
In a way.
Yes. Yeah, that's how I like thinking about it. You're cutting out the part that is like the misspelled word, if you think about it, right? Mm-hmm. And then you're saying, oh, let's put the correct spelling in. Let's just spell check it. Mm-hmm. So it's very similar to that. And I think what's interesting about this is some people that have sickle cell may decide to do a bone marrow transplant. So the cells in your bone marrow are what then create the red blood cells that for people that have sickle cell are that different shape that's causing all of the symptoms and the issues. So if you can fix the cells and say you get a transplant from someone that doesn't have sickle cell, and you take their cells and you put it in your bone marrow, then you're going to start creating healthy, normal red blood cells. Mm-hmm. But the issue with that is it's a transplant from someone that, all right, you're matching on a certain number of things that, HLA types is something we mention in terms of like, okay, are you a match? Right? I'm sure we've all seen medical shows, Grey's Anatomy, The Resident, whatever it is, where it's like, oh, are you a match or not? Right? When you go to donate a kidney, whatever it is. But you're not 100% the same genetic. You're not an identical twin, right? So what's cool about this CRISPR technology is that we can take the patient that has sickle cell, take their bone marrow cells out of their body, essentially fix them with this CRISPR, this copy-paste spell checker, then put it back in their body. It's their own cells, so their body isn't going to be fighting it. That's also an issue with transplants is your body's like, hold on, these aren't my cells. This is a foreign invader. I got to kill these cells. So when you're transplanting like an auto transplant, it's your own cells going back in, you're going to have way less issues. So it's really kind of like a better version of the normal bone marrow transplant that does not have great rates in terms of survival afterwards. People do, but it's scary. If you're deciding to do a bone marrow transplant when you have sickle cell, that's a very hard decision, I imagine. So I'm hoping this is going to be something that's available in, I don't know if I want to say, but within years where people have this option to do this, and it will change genetic conditions. And to have the word cure on the table is so huge. Life-changing.
That is life-changing.
It definitely is.
And it would be such a wonderful, wonderful thing that the Black community would be able to promote because we have so many people that have suffered from this, and it seems that, it was just a condition that, there was no light at the end of the tunnel, but we do have a light at the end of the tunnel with CRISPR technology. It sounds fascinating. But we want to thank you so much for being with us today, Kira, because you are a wealth of information.
Yes.
Hopefully we will have you back again very soon.
Yes. Thank you. Well, thank you so much, Bev and Lady Elaine, for having me on and talking about what's just so important. And I just also want to say, because I don't think I actually verbalized it during the episode, but I just so appreciate you guys for providing this information and lifting the veil on so many of these topics that really need to be talked about. And I really hope that you guys just keep growing as a podcast and having new listeners. And just thank you so much on the behalf of just, humans to be highlighting these really important topics and doing it in such an easy way that people can listen and just relate to you.
Thank you.
Thank you
appreciate
so
those
much.
kind words.
This is a shocking statistic. The National Institutes of Health, or NIH, the world's largest funder of biomedical research, squanders an estimated $200 billion of taxpayer money every year on ineffective animal experiments for human diseases. The NIH reports that failure rates for novel drugs occur in about 95% of human studies, despite showing success in preclinical experiments using animals. Animals and humans deserve better, which is why scientists for the People for the Ethical Treatment of Animals, aka PETA, have developed new strategies for replacing the use of animals in experiments with human-relevant methods. Advances in human-relevant research technologies hold tremendous promise to revolutionize biomedical research and usher in the age of personalized medicine, a topic we explore extensively on DNA Today. Head over to peta.org/New Deal to learn more. Again, that's peta.org/New Deal. For more information about today's episode, visit dnapodcast.com, where you can also stream all episodes of the show. We encourage your questions, comments, guest pitches, and ideas. Send them all into info@dnapodcast.com. Search DNA Today on Twitter, Instagram, YouTube, Facebook, so you can connect with us there. And a favor, please rate and review the podcast on Apple, Spotify, or wherever you listen. This truly helps us climb the charts and allow more genetic nerds like yourself to find the show. DNA Today is hosted and produced by myself, Kira Dineen. Our social media lead is Corinne Merlino. Our video lead is Amanda Andrioli. Thanks for listening, and join us next time to discover new advances in the world of genetics.
The genes of you and me, the genes of you and me, they're all made of DNA. We're all made of the same chemical DNA.